Hey everybody, welcome back to the channel. So today we're going to do a deep dive into smart contracts, more specifically how the Ethereum Virtual Machine, also known as the EVM, handles our smart contracts that we develop using Solidity. With that being said, let's jump straight into the video. So there are two main methods we can use to interact with the blockchain. The first one is writing to it, and the second one is reading from it. So exploring the first track, which is writing to the smart contract or writing a contract to Ethereum. If you think of it, we as Solidity developers develop Solidity source code that meet certain requirements and needs. And the Solidity source code looks something very similar to this. You have your variables, functions, any events. This one doesn't have any events. And once you have this Solidity smart contract, you want to compile it, right? You use the Ethereum Virtual Machine, whether it's in the form of Sol-C, which we'll be doing today, or we do it using Remix. Whatever your method of compilation is, you compile it down to two things. One is the ABI, also known as the Application Binary Interface. We'll get to that in a moment. Before we do, let's take a look at the second thing that is produced when compiling smart contract, and it's the Byte Code. And as the name suggests, it's literally the Byte Code representation of the Solidity smart contract. The Ethereum Virtual Machine is not able to directly understand that Solidity smart contract code. It converts it into Byte Code. Byte Code is something that the Ethereum Virtual Machine is able to understand using a set of opcodes. So for example, if you want to execute an addition operation, you would use the opcode 0, 1, multiplication is 0, 2, so on and so forth. So when you think about it, the smart contract that is doing all of these things that we as humans understand because we wrote it, the compiler has to break it down so the virtual machine can understand it. And this is what all of these operations that we write out break down to, right? It's a bunch of these operations, and we'll take a look at what that looks like in a moment. So let's go ahead and generate some byte code from our Solidity smart contract. And before we do, let's take a look at what the smart contract actually does. This is a very simple, straightforward smart contract that has a number variable, and we can use the function store to pass in a new number, and it's gonna update that number variable here. We also have the ability to retrieve the number at the time of calling this function. Pretty simple, straightforward contract. So let's go ahead and open up our terminal, and what we're able to do here, and again, make sure you also have Sol-C installed. I have 8.10 installed. So what I'm able to do is within the directory, say Sol-C, and then you want to pass in the bin flag, which essentially tells the compiler, I just want the binaries, and then followed by the directory of the smart contract. So if I'm not mistaken, it should be in contract, and then the file itself. And as you can see, it's gonna give us the binary as just an output to the console. If we want to save it to a file, we can do that by passing in a -o flag and then giving it the directory of the file that we want. And you'll see that it creates this same output in a file format. Anyways, so taking a look at the binary just really quick, you'll see the first thing is 60, and the format of this is opcode followed by the data that the opcode is going to be manipulating. So in this example, we have 60, and if we take a look at our cheat sheet, we can do Control F 0x60, and it's doing a push, essentially placing a 1 byte item onto the stack. So with our output, we're putting this 1 byte item, which shortly follows the push opcode here. So another thing that you can do is you can see the function signatures of all of the functions that you defined in your Solidity smart contract code by just encoding it. So we can do that by taking a note of the function name. So let's take a look at store, and also taking a note at the data type that we pass in as parameters. In our case, we pass in a uint256. So with those two pieces of information, what we can do is go into our console, and using Truffle console, I can encode that function and get the function signature in the form of byte code and find it within this binary output that I got from my smart contract. So in order to get the byte code representation of a function signature, what we do is say web3.eth.abi.encode function signature, and we pass in the function name within quotations. So ours is store. We also have to specify if we have any parameters that we pass in. In our case, we do. We just have to specify the data type. In our case, it's uint256, and close that parenthesis, close the quotations, and then close the parenthesis again. So if we do that, it's going to give us output. Essentially, if we take what is given to us after the 0x prefix, we can do a control F on the output, and you'll see that we find that same function signature within the binary output of the storage smart contract that we just compiled. So you're like, okay, cool. So we have these function signatures that are embedded within our binary. And if we take a look at our diagram, this bytecode is essentially what's deployed to the blockchain network. So how do we go ahead and interact with these functions and using their function signatures? Well, that's where the ABI comes in. So just like how we had knowledge of the function that we wanted to interact with, in our case, it was the storage function, and we knew that it was going to accept a UN256 as a parameter. We knew that, right? Because we developed the smart contracts. However, if anybody wants to interact with your smart contracts because it is on a public network, for example, or even your decentralized application that you're building wants to interact with your smart contract, it has to have that same knowledge that we had of being able to say, all right, I know the function name is called store and it accepts a UN256 number as a parameter. So let's take a look at what an ABI looks like so I don't lose you too much. Let's exit our truffle console, and using Salt-C again, what we can do is instead of saying --bin, we can say --ABI, and let's just output it to the same directory as well, and that's going to give us an ABI right here. So I'm going to prettify this real quick, and you'll see that we have all of our functions. We just have two functions. One is the retrieve function, and the other one is the store function right here. We have everything we need, right? We have the inputs that we need. In our case, if we look at the store function, it has inputs. It has the UN256 as the input, which again is all we need, along with the name of the function to encode and figure out what the function signature would be. So right, this is where the ABI comes in. So our decentralized application would come into here, extract the function name that we want, extract the types of parameters that we need to pass in, and then take what a user, for example, passes in as a number, encodes it all together, and sends it to the EVM to execute. So cool, now that we have our ABI generated using our Salt-C, let's say you want to generate both the ABI and the binary. So what we can do is say --ABI as well as --bin. So I'll have to specify the --overwrite flag, which will allow us to overwrite the existing files. As you can see, that ran successfully, and I was able to get both the ABI as well as the binary in one shot. So let's take a look at the under the hood operations that go behind actually calling a smart contract function or triggering a smart contract function, whether it's from some type of API or a decentralized application that you are building. All right, so let's open up our truffle console. So again, let's take a look at our smart contract, and let's say we want to call the store function. Well, all we need to do is encode the function and get the function signature. That's what we did here when we did web3.eth.abi encode function signature. So with this in mind, we'll just keep this in the back of our heads or note it down somewhere. Again, if your decentralized application is doing this, it's probably storing this in a variable. And then from there, what you'll have to do is encode the parameters that you have to pass in. In our case, we have to supply a number, more specifically a UN256. So what we can do is, in the same manner, we can say web3.eth.abi.encode parameter and pass in two things. The first thing is the data type, so UN256 for our case, and the second thing is the actual data that we want to pass. Let's say we want to update the number to 100 and go ahead and run it. So you'll see that it went ahead and encoded this parameter. Now whenever you want to call this function, right, with this function signature that takes in a UN256 number, you also have to supply the actual number itself along with the signature itself. So how do we do that? We can do that using web3 again. So you say web3.eth.abi.encode function call, and we have to pass in two things. One is the snippet from the ABI that identifies the function that we want to call. So if you look at the ABI, let's prettify this again. We needed, again, the name of the function, and we also need the function type, and then we also need the inputs that we need to specify. So by providing these three parameters, what we're able to do is generate this function signature that I was able to manually generate earlier. So that's the first parameter that we have to pass. So let's go ahead and copy that. Okay, so I just went ahead and copied the command I'm going to use. So this is the first parameter, which is in the form of a JSON interface. And again, I literally just extracted it from the ABI using these values that were generated, which again is manual right now because we are just learning. However, your decentralized application will do this in the background. Anyway, so the first parameter is done. The second parameter we'll have to pass in is the actual parameter values. So in our case, we have to specify a UN256 number. So we pass in the parameters using brackets. So we'll just say number 1, and I believe, let me make sure really quick, and yes, we will have to put them in quotes, and it knows that this is going to be of type UN256 because we specified that in the JSON interface. So yeah, this is going to give us the encoded function call that we have to include as the data of a transaction that we send to the Ethereum blockchain. Alright, anyways, Truffle console is being really weird, so I just decided to take the command I was going to send, that web3.eth.abi.encode function call, passing in the ABI interface of the actual function that we want to call, which is going to specify the function name, the type of the function, the data types that we have to pass in as parameters, if any. In our case, we do. And then for our second parameter, we pass in the actual parameter that we specified that we're going to pass. And then we're just going to store the return value into this data variable and then log it out to our console. So let's go ahead and run this script, and you'll see here that we are returning the bytecode for that function call that calls the store function on the smart contract and passes in this number as a variable. And yes, of course, there's a lot more that we'll have to specify, such as who's sending the transaction, where the transaction is going to, or in other words, the smart contract address, as well as the nonce, the gas price, and so on and so forth. If you haven't checked out the previous videos where I go over how to send a transaction to an Ethereum network, definitely check it out. You'll see exactly where this piece of data fits in as a parameter to that transaction. So this was a really nitty-gritty under the hood view of what the EVM is doing when we are working with smart contracts and compiling them and deploying them to the Ethereum network. In the next video, we're going to take a look at how we can use Golang as well as any other Web3 library to be able to do this very seamlessly. So a lot of the things that we saw today was very manual, but however, with Web3 libraries such as Go Ethereum or Web3j or Web3js, it does a lot of this conversion and encoding for us. So all we have to do is just say, hey, I want to call this function that lives on this smart contract, send this transaction. So we'll take a look at how to do that. Thank you much for tuning in. Again, if this video was helpful or you learned something new today, make sure you give it a like, comment any thoughts that you may have, and make sure you subscribe and click on that notification bell so you are notified every time I drop a new video. I will see you in the next one.